Hello and good afternoon. We are Group 4, and today our presentation is about analyzing, evaluating, and recommending on the immediate action plans that should be considered for the existing 3G infrastructure. But first of all, let me introduce our group members. I am Asma, Sangin, Huaxiang, and Foyu. So this is the outline of our presentation. So let's start with the introduction of third generation 3G. So as we know that the third generation system has been introduced at the beginning of the 20s, including along with voice, multimedia, message support, MMS, SMS services, and web browsing on phone devices. 3G networks offer users advantages such as new spectrum to relieve overcrowding in existing system, more bandwidth, security, and reliability compared with 2G, interoperability between service providers, fixed and variable data rates, always online devices, and also 3G use IP connectivity. IP is packet-based, not circuit-based. So now let's see what is the problems or challenge in 3G. So there are some issues in deploying 3G such as the cost of upgrading base stations and cellular infrastructure of 3G is very high. Requires different handset, and there is the issue of handset availability. So as we know that 3G handset is a complex product. Roaming and making both data and voice work has not been demonstrated. Also at higher power requirement, more bits with same energy bits demand a large handset, shorter talk time, and larger batteries. Also, base stations need to be closer to each other, which means more cost. And the last thing, tremendous spectrum license cost, new deployment cost, handset subside to subscriber etc. So now let's move to see what is 5G. The continuous increase of mobile data traffic drives the emergence of fifth generation 5G wireless communication. So 5G planning aims at higher system throughputs, spectrum utilization, energy efficiency, and cost efficiency than conventional networks. To achieve the above key performance metric, more spectrum resource is exploited for 5G. So the vision has become that the fifth generation supports a multi-service networks and diverse range of frequency that have a different set of performance and the requirement of the services. So now let's see 5G services. So as you know, 5G will carry high peak rate per participant, handle a huge number of devices, provide better coverage, increase the capacity, provide better reliability, offer low latency. These capabilities will be provided at approximately the same level of energy and cost used in networks in these days. So this slide it's about mobile operators. To get there, mobile operators must invest in all network domains, including spectrum, radio access network, infrastructure, transmission, and core networks, because mobile operators are keenly aware that they will have to increase their infrastructure investment in this technology. So as we can see here from the chart, the 5G layer, small cells, and additional macro sites will represent a greater proportion of network spend between 2020 and 2025. So we grouped the infrastructure cost for the current network footprint into four areas: upgrades to the traditional network, the addition of new macro sites, creation of the new 5G layer, and the addition of small cells. At present, most expenditure go to the traditional network. However, as operators densify their networks through additional macro sites, small cells, and the 5G layer between 2020 and 2025, so this area will represent a great proportion of TCO. Here, as we can see from this chart, it represents the growing demand related to the new 5G use cases will trigger investment across all network domains. We have new spectrum, macro network densification and layer upgrades. This will also increase vibration and core and features. So now I will pass to my team member to continue with the methodology.
Uh, I'm gonna speak about the methodology of taking such a as a network strategy of this project. First of all, we have two plan and we will compare between them. We choose it an area in Malaysia which is it has enough data how many number of users and its geographical area, which it is UPM University. First, we guess that all the base station in the university it will be removed and design 5G base station for there, and we will see how much it will cost, how much time it will need, what we do need to do it, or instead of doing that, we will just increase the spectrum by spectrum refarming or spectrum sharing. This project, first of all, for both those plans, we should, as a team, we should know the geographical area, the weather of that place, potential users, hardware configuration, channel characteristic, the equipment that is needed, the cost, how much it will cost for both of them, which one is better, and time expectation with the future usage of those base stations, and our recommendation. Here, the University of Putra Malaysia. As we know, the university, first as a geographical area, University of Putra Malaysia, as we know, it's located in the Serdang, and it is 1,214 hectare pieces of land, which is over 1,100 of that area has been turned into the University Agricultural Park. UPM is made of 16 faculties, 16 centers, 9 institutes, 1 school, and 1 academy. How is the weather in Malaysia, and what is its effect on the bands, on the frequency? Malaysia, as we know, it's one of the tropical regions. So usually the weather is hot, humidity, and rain. The humidity in Malaysia is very high because it's one of the tropical region. It's located on the equator line, which is 84. We can relatively, it's 84 to 88, and the range of rain is massive, and the rain drop in Malaysia is bigger than the usual countries. How about the number of users? The number of users in university, inside the camps and the hostels there is around 30,000 students with Malaysian, included Malaysian and international. What is the OR system modeling? We should know what is the hardware configuration, what is the chip that are supporting 5G is N20, as it is here, N257, 260, 261, and 77, 78 and 79 with 41. The companies that supporting 5G, Huawei, Telecom, Samsung, and the spectrum that is available for 5G is C-band, which is less than 6 gigahertz, and above C-band, which is the millimeter wave band, above 6 gigahertz. The network is enhanced mobile broadband, with ultra reliable and low latency with machine type. The frequency band that's available for 5G is C-band, which is one of the most important core spectrum, which is start from which is less than 6 gigahertz, 3.4 to 3.8, and which it has a lower frequency, but the wavelength of it is taller. And we have the millimeter wave, which is one of the promised technology for 5G in the future. They are working on it now. It has a larger bandwidth, higher throughput, faster data rate, and its capacity is more than the C-band. Millimeter wave bands frequency will start from 30 gigahertz to 300 gigahertz, but from 10 to 30 as well, it can be considered as a millimeter wave because it has this. They are sharing the same propagation characteristic. Why in this project, in case if we wanted to build 5G in the UPM, why we will choose C-band? What is the reason? The reason for that, it is not affected easily by the rain. As we said, Malaysia is raining usually, and humidity won't make it to lose the signal power quickly. As well, C-band can transmit and receive over long distance because it has a lower frequency, so its wavelength would be shorter, taller, sorry, compared to the millimeter wave, and its electromagnetic wave can penetrate wall. easier than the millimeter wave band to provide indoor facility. As we know, the majority of the students, they are inside the building. My friend Haoxing gonna present the rest from that.
Hello, thank you, Ashley. I'm Hao Xiang. This part is about the cost of the UPM. As shown in this picture, the geographic area of the entire UPM is represented by a red box, and it can be found that the entire UPM can be divided into two large areas. The first part is the high density areas, and this part has a large network demand and requires the use of micro base station and micro small base station to cooperate with each other to ensure the network quality. And the other areas is most of the public areas, so it can be built by the micro base station. The black circle is micro cells station with a radius of 300 meter are covered. Next. This part is about regional analysis, and it can be seen from the figure that the high density area of UPM account for about 35%. So the micro base station and small cell stations needed to deployed in this part to improve the network quality, and small cell stations is arranged in the teaching building area, and pico base station arranged in main office. You can have a total areas of 11.03 square kilometer. So we need 25 microbase station. Most of teaching building are 3 to 5 floors. So coped with the analysis of environmental factors and others, we need 270 small cell base stations, and also we need 18 pico base stations. Next. This part is system design in 5G. There will be in 25 mega cell stations in that areas, each 600 meters, and 270 small cell base stations in each 250 meters, and there will be 18 pico base stations in that areas in each 50 meters. Next. This is the 64 transmitter plus 64 receiver antennas. Next. This part is the 5G micro cell station, and is usually installed on ground with a transmission distance of about 300 meters. And the next is 5G small cell base station. It is more convenient that micro base station, and it's mainly used in high density areas. Next. And then this part is pico cell stations. Pico base stations are often used indoors, such as meeting rooms and small reports halls. Next. This part is 5G micro base station cost. It divided three parts. The main equipment cost 200,000, and the power supply team facility cost 30,000, and civil construction. This part cost mainly for building signal towers and building computer rooms and others. The total cost is about 100,000. Next part. This part of base station analyzing compare with the 3G or 4G. More base station are needed for 5G, and the cost will be increased. A small base station is about 50,000, and the construction, the cost of the Pico base station is 50 RM. Base station upgrade can save costs about 30%. The upgrade cost for each 3G base station is 231 thousand. Therefore, this project we need to upgrade for 3G base station and 21 new micro base station and 250 new small base station and 80 pico base station. Next. This is a project budget form, and its total cost 2012 million and 554. So next part. And this is the maintenance cost. In addition, construction cost, and it's understood that the power consumption of 5G base station is 2 or 3 times that of 4G base station. That's all. My friends, some of you will introduce the next part.
Hello everyone. Thanks for Haoxiang. I'm Fuyu, and I will talk about the implementation plans. First of all, we should research. We need the plan areas that we need improvement, and we need improve users' dimension for 5G communication, and we also plan for the intro project. And the next is the planning times and cost. In this part, we need investigating existing 3G base stations in area, and we also schedule the time of the project and calculate the corresponding cost, and we also anticipate difference as the project progress and develop solution. And the last is we need start to improve the 5G base station. In this part, we need to determine the approach suffered such as engineering, construction, personal, and so on. We also strictly control the construction states to reduce the risk of the error. This is the data of the base requirement of the 5G. It's like the peak data rate we will set at 100 kbps, and the capacity and density is 1,500 bps hertz kilometers, and so on. And we also want to set the user plans liters is 0.5 ms, and the control plans lecture is 10 ms. We also set the ability and the reliability is very high. This is our time expression. We set the time in 4 steps. The first step is communication improvement plans. In this part, we need the research, and the past plans we need the 3 days. And we set it at 1st May 2021. We finish this, and for 1st May 2021, we also need when we pass the plan, we need ready for the work. We need determine user analyze and design the team and pathway design. We need the 11 days. We said we start at 5th May in 2021, and the next slide is build the 5G station. In this station, we also set 3 steps. The first step is we buy the equipment and find the teams to build this. We need 3 days. And the start of construction, we need 36 days. This is our risk prediction and solutions. We have the internal factories. The problems maybe is interfine construction equipment and the construction staff shortage. We need pressure the equipment, the quality of equipment should be street-based, and we also before the start of construction space, equipment shall be prepared to prevent equipment accidents and construction. The the other problem maybe is capital chains is broken. When this problem we need set aside some money in approved at the beginning of the project, and we also, after the problem arises, the financial teams will solve the valuation problems quickly, and we also have the time schedule problems. So we need to do a good job of reserving times to improvement expense from effect progress, and we also set the different schedule every 2 weeks. And this is the internal factors. We will meet the weather problems when making plans. We need for consider the environment factors of the area, such as raining window and so on. So we also allow sometimes to prevent the construction from being unable to be carried out due to bad weather. And we also have challenge in the number of users was found. Requirement minor improvement to the equipment. We need the design departments to quickly understand the requirements and put forward the best improvement plans. We also may meet the other projects are under the construction. We will avoid the conflicts with other projects and do our best research. That's my part. Next, my friends will talk about
Here, there is two alternative way. Instead of removing all the base station that there is in the university or any area, to two different way, which is spectrum reforming, spectrum sharing. These two ways, they can delay the investment of 5G. What is the spectrum reforming at the very beginning? The term of reforming refers to replacing an existing technology in particular frequency band with a new technology in the same band. The spectrum reforming is basically allowing incumbent license holder to utilize the allocated spectrum for some other servers or relocation of license to some other band from the existing band and reuse this band for the other radio services. We should know what is the benefit of it. Of course, at the very beginning, it will be a cost-effective way. The energy consumption would be less. And another thing, another benefit is that it has a lower frequency. That means provide much better coverage. Lower frequency reach farther distance. And it has less, because it has less penetration losses than higher frequencies. And as well, it will enhance the quality of service because it will be fewer base stations. That means fewer handovers. What is like any other technology, this technology as well has some challenge. As a network strategy, we should overcome those well as well. First of all, it says operator must have a sufficient continuous spectrum to support the simultaneous operation of 2 or 3 technology and frequency bands. Simultaneous mixed of a frequency band present challenge regarding to bandwidth as well. The same operator should be using both sides of the spectrum adjacent to the driving point. Adjacent channel interference must be dealt with using guard bars. As well, we have spectrum sharing, which is now we are using it majority of the base station of 3G, depending on the 4G, and 5G as well. In the developed countries, they installed 5G base station as a non-standalone, or in Malaysia, if we did it as well, it will be non-standalone. That means it will depend on the 4G base station. And for this one, we have two ways for a static spectrum sharing and dynamic spectrum sharing. What is the benefit of it? As well, it will be cost saving. It will have a benefit for the environment by reducing the energy consumption, less radiation, the customer experience. It will be sharing can lead to better quality of service, better coverage, higher data speed. Coverage obligation can be met as well. But let's not forget 3 important points. As long as we did such a thing, we came as you did spectrum reforming and spectrum sharing without removing all the base station. We turned off, but at the same time, we have to do some stuff. Even if new spectrum is introduced, mobile operator will need to increase their infrastructure investments significantly. Why? To overcome certain limitation and to cope with the growing traffic. Second thing, we should not forget, as a new spectrum is introduced, mobile operator will need to improve 2 things, which it is radio interference and antennas. Why? To increase efficiency. In many highly populated urban areas, even though if we use spectrum sharing or spectrum reforming, we do have to add more small cells and more micro cells maybe. But if we compare it with the first way, that we use it, that we deleted, that we removed all the base station after we turned off 3G base station and redesigned it again, it will cost us a huge amount of money, and it will need a lot of energy consumption, which is one of the problems for the climate change as well. So by doing this way, we will save a good amount of money, and we use the base stations because it will be a huge amount of loss of money if each time we upgrade each generation, we turn off the base station and leave it. So what would be the future use of base station? It will be sharing infrastructure that will continue for those base station, even if it is 3G base station or 4G or 5G. And there will be passive infrastructure and active infrastructure. What I mean by passive infrastructure, that means non-electrical infrastructure there will be at a site, like power supply, management system, physical element. And active infrastructure, I mean by electronic infrastructure. Here we mean by antennas, transceivers, base station, backhaul network, and so on. What is our recommendation for the devices, for the machines, for the phones that we are using it? A designer or those companies that they are supporting telecommunication or 5G or 3G, they should design such a kind of devices that support network implementation in standalone. It should be support all protocol for standalone as well. And the same, standalone, it will support non-standalone, and non-standalone supports standalone, because this will continue. Now we are using 5G, but after maybe less than a decade, there will be 6G as well, and so on. The devices, of course, those that they are supporting 6 GHz should support millimeter wave as well, standalone or whatever. Our recommendation in this project is the devices and the base station equipment should be virtualized. So it doesn't have to be changed in upgrading to another generation. This is number 1. Number 2, the devices shouldn't be that much expensive when we upgrade, when there is another generation will be installed. So by changing those devices, those equipment, those machines, we won't lose a huge amount of money. They shouldn't be so much expensive. And as well, in our company, we should invest in research and development, because this can enhance the innovation of a company and reduce the costs. And this is the reference that we have used. and thank you.